Okay folks, here is another quick video from section 4.1. We're going to do, this is one of the examples from the book, so we're going to take a look at an airplane descending to land. So we've got an airplane cruising at a height of 10,000 meters. It descends to land. The table shows the height of the plane every minute after it began its descent. The height of the plane changes at a constant rate. And here's our data. So it says write an expression for the height in terms of the time since the plane began its descent. If we take a look at the, if we take a look at the table, we can see our pattern start to emerge. The time in minutes is going to be our independent variable, and the height of the plane is going to be our dependent variable. Right? So the height is going to depend on the time in minutes, and the time in minutes is going to determine the height of the plane. So we've got that relationship taken care of. So for the pattern in the table, you can see that when the time goes up by 1 minute, the height of the plane goes down by 300 meters. So it drops by 300. Up by 1 minute, down by 300 meters. I guess I don't need to put the units in here. I didn't put them on the other one. Up by 1. Up by 1. Every time the minutes go up by 1, the height drops by another 300. Okay, so, and again, last one minus 300. All right, so now we're going to try and put together the equation. In this case, the zero value, or our constant term, is given. So that's shown. So this is going to be our zero value, or our constant term, or our starting value. Everything is going to get referenced off of that 10,000. So when we take a look at that 9,700, that is going to equal our constant term, 10,000. And we're going to take away 300 one time. Okay, let me make those red, I guess. Our 9,400, we're going to start back again at our zero value at 10,000, and we've subtracted 300 twice. So 10,000 minus 300 times 2. 9,100, we start again at 10,000, and we subtract 300 1, 2, 3 times. And last but not least for the table values, that 8,800 is 10,000 minus 300 4 times. So the relationship that I hope you see is that the time in minutes, in this case 1 minute, we subtracted 300 one time. 2 minutes, we subtracted 300 2 times. 3 minutes, we subtracted 300 3 times. 4 minutes, we subtracted 300 4 times. So that means that for t minutes, our general term, we'd start at 10,000 to get our height, and we would subtract 300 t times, right? So when t is 1, we subtract it once. When t is 2, we subtract it twice. 3, we subtract it 3 times. 4, we subtract it 4 times. If t was 57, we'd subtract it 57 times. So when t is just a general variable that could be anything, we're going to subtract it t times. So this gives us our equation, h equals 10,000 minus 300t. So I've actually kind of done A and B together. So when we look at question A, it says write an expression for the height in terms of the time since the plane began its descent. So in A, our expression for height is, that's the 10,000 minus 300t. That's going to be the expression. And for B, our equation, that relates the height of the plane to the time since it began its descent is going to be h equals 10,000 minus 300t. Right? So the expression doesn't have an equal sign. The equation does have an equal sign, and it brings in our dependent variable. So height equals and 10,000 minus 300t. So remember, dependent and independent variable. The independent variable is your input, and the dependent variable is going to be your output, if you want to use language that you would have used in probably grade 7 and grade 8. This is like an input-output table. So there's A and B done. Question C says, what is the height of the plane after 15 minutes? So in question C, they have told us that the height is what we're looking for. We want to know what the height is. I can fix that question mark. after 15 minutes. So that means when t equals 15. All right, so we're going to use our equation to determine the height. Our height will equal 10,000 minus 300 times 15. Okay, so that's going to equal 10,000 minus, okay, so 300 times 15. 3 times 15 would be 45, so this is 4,500 then. And 10,000 take away 4,500 is 5,500. Because this is asking us a word question, we should give it a word answer. So the height after 15 minutes is 5,500 meters. Okay, so that is question C. And last but not least, I think I can squeeze the last one underneath down here. D says, how long after the beginning of its descent does the plane land? So what is going to constitute landing in this case? What you want to think of is what height you'd be at when you landed. What's your height above the ground? Well, when you land, you're at the ground. So landing would mean that h would equal 0. And we want to know how long. So the time is what we are looking for, right? So down here, I'm going to fill in h equals 0 to my equation. So instead of h equals 10,000 minus 300t, it's going to be 0 equals 10,000 minus 300t. And I'm going to solve for t. So you can do this a couple of different ways. I think for me it makes sense. It's not balanced because I've got variables and ones on one side and I've got nothing on the other side. So I'm going to add 300t to this side, and I'll add 300t to that side. When I do that, 0 plus 300t is 300t. And I get a 0 pair over here, minus 300t plus 300t. That's going to make nothing. So 300t equals 10,000. And finally, to solve, I don't want to know what 300 times the time is. I want to know what the time is. So I want 1t. So we're going to divide by 300 on this side, divide by 300 on that side, and that is going to give me my answer. So t is going to equal 10,000 divided by 300. So 10,000 divided by 300, if you do this as a decimal, comes out to 33.3 repeating, okay, as a decimal. As a fraction, that's going to be 33 1/3, if you like. And this gives us the time in minutes. So how long after it begins its descent does the plane land? The plane lands 33 1/3 minutes after beginning its descent. Okay, and that would be our answer for D. The only other thing you could do with this, and this is fine by the way, just take a second and ask yourself if you could do that in minutes and seconds. So if it's 33 minutes and 1/3 of a minute is 60 seconds. So what would 1/3 of a minute be in seconds? Okay, if you think in 20, you would be right. So 33 minutes, 33 1/3 minutes, I'll do this over here. (33 1/3 minutes) would be 33 minutes, 20 seconds. Okay, and again, that's not necessary at all. I just wanted to point it out because it's an opportunity to extend things a tiny bit. Yeah. The only other thing I want to mention about this question is having a constant downward speed like this, a constant rate of descent, is probably not realistic. The closer the plane gets to the ground, it's going to slow its descent for a gentler landing. Okay, so that's, if that crossed your mind, then good. That's probably very correct. Okay, I hope that was useful. Thanks.